Hello, welcome. In this short video, let us look at the Laplace transform of the cosine integral. Laplace transform of the cosine integral. The cosine integral is defined as Ci of t equals integral t to infinity cos u divided by u du. So this is the definition of cosine integral. Our goal is to find the Laplace transform of this function. So we want to find Laplace transform of this cosine integral. This is our goal. Let us denote f of t is equal to this cosine integral. That is integral t to infinity cos of u over u du. Now by taking derivative, f dash of t is clearly equal to minus cos t over t. Therefore, t times f dash of t is equal to minus cos t. Now by applying Laplace transform on both sides, we have Laplace transform of t times f dash of t equals minus Laplace transform of cos t. And by using the formula for Laplace transform of t times a function, we have minus 1 derivative with respect to s into Laplace transform. Derivative with respect to s of Laplace transform of f dash of t, which is equal to minus s by s square plus 1, because Laplace transform of cos t is s by s square plus 1. And again, by using the formula or the property of a Laplace transform for the derivative, we have minus d by ds of s times f of s minus f of 0. Here f of s is the Laplace transform of f of t, and this should be equal to minus s by s square plus 1. And since the derivative of f of 0 with respect to s is 0, so we can ignore the second term and we can cancel the minus signs. So we are left with the differential s of fs equals ds into s by s square plus 1. And now we can solve this differential equation by integrating on both sides. So we have s times f of s is equal to integral of s times s by s square plus 1 ds. And clearly this integral is equal to 1 by 2 logarithm of s square plus 1 plus a constant k. Therefore, s into f of s is equal to a constant plus 1 by 2 logarithm of s square plus 1. Now we want to find the constant k, the value of the constant k. By using the final value theorem, limit as s tends to 0, s times f of s is equal to 1 by 2 into limit s tends to 0 logarithm of s square plus 1 plus the constant k. So by using the final value theorem, this is equal to limit t tends to infinity f of t. And by the definition of f of t, this is equal to integral is equal to limit t tends to infinity integral t to infinity cos u over u du. So this is clearly 0 because as t tends to infinity, both the limits become equal and the integration should be equal to 0. So the left hand side is clearly equal to 0. On the right hand side, this limit is clearly 0 because as s becomes 0, log of s square plus 1 becomes log 1, which is 0. And the constant is k. So this is equal to k. Therefore, the constant k is equal to 0. Hence, f of s is equal to 1 by 2s into logarithm of s square plus 1. That is, the Laplace transform of cosine integral is given by 1 by 2s into logarithm of s square plus 1. Thanks for watching.